Right. So in OSPF, when you have point to point, there's only two routers. When there is two routers, there is no chance of duplication of update. But when there are more than two, there are chances that same update can be forwarded by multiple neighbors. For example, a link has gone down. This sends to everyone. And this will think that the others have not received, I have to forward it. So this also forwards. This will think that others have not received, so this also forwards. Likewise, this will also forward the same update. And whatever this forwarded, this guy will try to forward to A. This is going to be a big mess. And this will also cause loop. Same information has been given to multiple routers by multiple source. Same information given by multiple routers by multiple source. That will cause problem. For example, if there are 30 students in my class, means I'm a student, I have 30 classmates. And to announce the holiday, if every student can announce holiday, what will happen? One will say, we have 1 day holiday. The other will say, we have 1 month holiday. Because he wants 1 month, so he will say 1 month. The other will say 1 week holiday. That will cause confusion. That is not proper. Who should inform holiday? The school management, like principal or someone like headmaster or headmistress, someone like that is authorized to announce holiday. Even the teachers are not allowed to declare a holiday. School management should. Teachers can propagate it to their own class student, not to other class. The class teachers are responsible for their class. They can announce only in their class. That will prevent a wrong message getting distributed or duplicate message getting distributed. Likewise, whenever there are many routers, to prevent duplication of update, if there is a change should be announced, but should not be announced by different source. There should be one authoritative source to inform the change. If any query need to be made, only to that authoritative source the query should be sent, not to everyone. That's why we need DR, BDR. Why BDR? If DR fails, we need someone who knows everything, so we have BDR. So this DR, BDR is needed only when we have Ethernet LAN segment. This means what? It's LAN switch. This is how we draw switch. Either we draw like this or we draw like this. Now, this says that this is a LAN, this is a switch. This is layer 2. So here, this means it's a layer 2. And the IP address of this will be what? Let's say 10.0.0.1. This will not be 20.0.0.1. Definitely this is going to be same subnet. This is also going to be same member of same subnet. This is one local area network in which these four routers are connected. Now, there is need for a DR and BDR. When we learned about the DR BDR election, we'll also be seeing how DR BDR is elected in coming pages. As of now, we know that should be a DR and there should be a BDR. And only with the DR and BDR, you might have noticed the routers form full adjacency, meaning they share the complete DBD. Between two DR others, till which state they go? Can you answer? Between DR others, till which adjacency state it goes? No. I'm asking. We have down state, init state, two-way state, extart state, extend state, full state. I'm asking between two DR others. Exactly. It won't go further. It won't do any exchange, so there is no need for extart. When there is no exchange, there is not possible of having loading state or full state. So with DR only, they inform everything to avoid loop, to avoid duplication, to avoid redundant copies of same update. Okay, so how to talk only to DR? There should be some special language. Say, for example, I had met a family in Chennai. When the outsiders are there in home, they will talk in some language which the outsiders can't understand. For example, that family was putting alphabet P in the end of every word and they were talking. It was literally like a foreign language. Every word they will add P to the end. Only the listener will know I have to filter the P sound and understand what the others are saying. For me, it was totally like one foreign language, all ending with P. Likewise, there should be a language which will make only DR to understand. See, this link has gone down. This is not a DR, this is DR other. It wants to update the change, the link failure to DR. So there should be separate a dedicated address. And this is the address. 224.0.0.6 is the address to which the DR router will be listening. Yeah. No other routers will be tuned to this multicast group. When a router is elected as DR, this is what really happens. The router is tuned to listen to this address. Any traffic delivered to this multicast address, DR can take ownership. DR can take it for itself. 224.0.0.6 is the multicast address which is used to talk to the DR. When I say DR, it also includes BDR. Both DR and BDR will be listening to this address. Now, when DR receives this new update, after synchronizing its own database, DR also need to update to every other routers. For that, what it uses is 224.0.0.5, which means what? All the other routers are listening to 224.0.0.5. Others are listening to 5, sending the update to 6. The DR, they are opposite. They listen to 6 and send the update using 5. This is how the message between the others to DR and DR to rest of the DR others have been exchanged. This is why we need two addresses in a LAN environment, two addresses. In a point-to-point environment, when I connect a serial wire, we call it as point-to-point. The reason is we don't have a LAN switch in between. We cannot have a LAN switch because it's a WAN link. The wire itself is called as WAN link. It cannot be connected to a switch. So only two routers can be connected to this wire. That's another story. We need to speak segment wise. This is one segment. Yeah, this is one segment. Now between these two, they will have full adjacency, and the priority will be always 0, no DR/BDR, and the only multicast address needed is to 24005. 6 is not necessary here. Whereas here, between this, there is going to be two addresses. 5 in order to update DR and BDR about the changes. 6 for the DR to inform the rest of the routers, other routers, about the change. Others will use the opposite. Sending is 6, listening is 5. Whereas DR, sending is 5, listening is 6. Did you understand why we need DR, BDR, and how the two addresses are used? All right. Yeah. Other DR others. And BDR will be a Hmm. 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 பாருங்க இங்க ஒரு லிங்க் ஃபெயிலியர் நடக்குது. இந்த லிங்க் ஃபெயிலியரை டிஆர் அதர் எல்லாருக்கும் சொல்லவும் முடியாது. காரணம் ஃபுல் அட்ஜசன்சி அலவுட் கிடையாது, 2-வே வரைக்கும் தான் அலவுட். அப்போ கொடுக்கணும்னா டிஆருக்கு மொத்தம் தான் கொடுக்கும். அது எப்படி கொடுக்கும்? இந்த காமன் அட்ரஸ் 224.0.0.5 அனுப்புனா எல்லாருக்கும் போயிடும். ஆனால் எல்லாருக்கும் அனுப்பக்கூடாதே. அப்போ சரியா 6ன்ற அட்ரஸை கொடுத்தோம்னா இதுக்கு மட்டும்தான் போகும், வேற யாருக்கும் போகாது. அப்புறம் இது என்ன பண்ணும், 5ங்கிற அந்த காமன் அட்ரஸ்ல அனுப்புவோம், அப்ப அது எல்லாருக்கும் போகும். சரி, alright. So not only the changes, even during the initial adjacency state, this is selected as DR, and now this router will send a DBD to this DR, and this DR only will forward to the rest of the routers. And the only all known router is DR and BDR. But BDR is a passive listener only. It is passive. It won't send any update to anyone. It will collect all the changes that is being sent as an update and synchronize its database. The database of BDR and DR will be same. If the DR goes down, then BDR takes the role of DR. Now there will be an election between these three routers to become a BDR. Between these three routers, if there will be one router with high priority, that will become the BDR. If the priority is same, the default priority is 1. If the priority is same, the bigger router ID router becomes the DR. Let's say this priority is 10, so this becomes BDR. Now what happens? This old DR comes back. What will happen to this? It will become DR other. Even if it has got priority 100, it cannot retain its old position because OSPF DR BDR election is non-preemptive. Non-preemptive meaning it has to wait for a re-election. Only then it can get chance. Even when there is a re-election, or say for example, this DR fails now, this DR dies. This DR dies. So what will happen? B will become DR. Though the priority is 10, it is going to be DR. The reason is DR is not elected. DR is only promoted. From BDR, one becomes DR. So now this becomes the BDR. Right. So that is how it works. Any question on this page? Let's go to next. You see, in the first chapter of OSPF, we learned that the sequence number makes the routers, when they receive the update, to decide whether to accept the update or ignore the update, or to send our own database to the sender. It all depends on sequence number. If the incoming LSA sequence number is higher, then this local router decides to update its database because incoming is higher, what it has got is lower. It means that a new update is coming, we need to update. Sequence number is what helps the router to check whether the incoming update is a new update or the same old update or the outdated update. Sequence number is important. For every change, if there will be a sequence number, then the sequence number should be of a big range. In a very large environment where 1,000 routers are there, changes will happen every now and then because you have thousands of router, and if two network per router, you get at least 20,000 network, 20,000 links. So there will be some wear and tear, some disturbance in some link that will shoot updates. An update needs new sequence number. So OSPF is designed to have this range of sequence number. Every time change happens, the sequence number will be incremented by 1, starting from this hexa value 0x8, 6 times 0 and 1. This is the first update going from one router. When that same router sends next update, this becomes 2. And then at last it reaches F. F means 15th update, no? And then becomes 1 here and 0. 1, 2, 1, 3. Goes like that. It's really quite long number, like 32 binary bits. If I need to write this in binary, it is 32 binary bits. It is written in hexa. That is why it is small in size. It's written in hexa 0x. Hexa. You see, this is 1 byte. 4 plus 4, 8 bit. This is 4 binary bit. 1 bit of hexa is 4 binary bit. So I got 8 bit here, 16, 24, 32. 32 bit, which is 4 byte. The front they put 0x to say that it's an hexa number. Now, this is the beginning. And once this all reaches F, this all reaches F, this 8 will get resetted to 7. That's the end. So that it can start again from here. So this should not confuse us. What I'm trying to say is once this all reaches F, this number resets to 7, so that when the new update is sent, it will go with 80001. 80000. And if you see, millions of sequence number can be produced in this range because you got 4 byte. It's like 2 to the power of 24. Do we need that many? Yeah, no. You may not need that many, but to be on safer side, they have got that many. Why I'm saying you don't need that many? Because every 30 minutes, OSPF will send the DBD to make sure everyone is fully synchronized by incrementing the sequence number. Even when there is no change in the topology, it is going to increment the sequence number by 1 and flood the DBD to everyone to make sure that everyone is fully synchronized, nothing missing. Additionally, every 1 hour, it will reset this sequence number. It will wrap every 1 hour. These 2 points are not known to many. Will RIP send will RIP send a periodic update? Everyone will say, yes, sir. Every 30-second RIP will send the periodic update. But when you ask someone, do any other routing protocol send periodic update? Any other routing protocol send a periodic update? Mostly they will say no. It's not a no, it is an yes, actually. OSPF sends periodically every 30 minutes, every half an hour. update to make sure everyone is synced. No, complete database, complete database. And then the sequence number gets wrapped, gets resetted to the beginning every 1 hour. This is to make sure the OSPF autonomous system will never run out of sequence number to send new updates. Right. In this story and all, we have learned in the first chapter itself with the flowchart. How do you know it's a fresh update? The newer sequence number, the higher sequence number, shows that the update that I am receiving is most recent. This command is the command that shows the topology or the link state database, OSPF link state database. We type show IP OSPF database. This shows with a sequence number. Yeah. In this example, like 48 seconds ago, this particular router has sent the update, and that is the 8th update. 8th update was sent by this router 48 seconds ago. 6th update was sent by this router 212 seconds ago. So you can see the sequence number. Let's go and see sequence number on the command line. This is one of the questions that you asked. This router has got 2 sides. Here we have serial. There won't be any DR/BDR election. But on this segment here, there are 4 routers. So definitely there will be DR/BDR, and this may be a DR other router also. This may be a DR other on this side. Whereas on this side, it is full adjacent. Okay, let me start the Wireshark to show you in the capture the sequence number. You can see router 2 is sending hello packets. Between point-to-point routers, there is only multicast, there is no unicast. Now I'm waiting for some packets from router 1. Okay, I see hello packet. And you can also see update packet. Once the update packet comes, okay, update packets come. Now let us see the sequence number. I'll stop the capture. See the first update coming from router 2. Because router 2 is the one with the bigger router master that is sending the very first update. Coming from router 2. And this is the sequence number. And now let us go and see there on the router. And there is also some more updates from router 2, but let's go to command line now. Then we will come back. Go to router 1. Show IP OSPF database. I can see the sequence number 2. Sorry, this one 3 coming from router 2. Sorry, this is packet sequence number. Don't see this. It's not OSPF update sequence number. OSPF update sequence number should be here. This is second update coming from router 2. And this is the update it is sending. It's talking about 10.54 25.32.34.0. It is this side network. And this router 2 is advertising about this link state to router 1 with the metric of 1 and the subnet. It will also advertise the subnet. Also, it advertises the loopback of router 2 with a metric. Network slash subnet metric. This is how the update will look like. So that's from router 2. Another update from router 2 is this. Do we have any other update from router 2? Here it is. Now, what is the sequence number, the last sequence number? 3. That's what we saw there. So this third update received 162 seconds ago. Right. Let's go back to presentation. Here we can also see this by typing debug IP OSPF packet command. Let's do that. I showed you in Wireshark. You can also see that in the command line. Every 10-second hello packets will come. So I can show you the hello packet. I think I showed you when I started the message type in OSPF chapter 2. But I'm going to do it again. Debug IP OSPF packets. I'm saying debug. So I want to capture the packet and show you. Look at this. I have received version 2 packet, means IPv4 version of OSPF, and it's type 1 packet, meaning hello packet. The length is 48. The router ID who is sending this to me is 2.2.2.2. It belongs to area 0. Then authentication type 2 means MD5 authentication. And then this is packet sequence number. This is not OSPF sequence number. The IP packet sequence. And then interface which is receiving it is this. That's what you see here. This output show debug IP OSPF packets. Right. All right. This chapter we started with this packet types. 5 packet types. Except for hello, for all other 3 like database description, LSR, LSU, there will be an acknowledgement sent. Right? Okay. And this is how the header looks. These are the things that will be inside the hello packet. I can also show you that in the Wireshark, much more detail it will be. So pick one hello packet coming from router 2, let's say. What do the hello packet contain? OSPF hello, if you open, it has got the mask on the link, the timer, and then the priority, the day timer, the information about DRBDR, because it's point to point, it is 00. And then if you go above, it says it's version 2, type 1, hello packet is type 1, length, the router ID, area ID. For area ID, there is 32-bit, no OSPF, 32-bit. This may be an interview question like how many bits are allocated for area ID If we ask router ID, everyone will know. It's 32-bit. Router ID is 32-bit. But for area ID, many do not know that it is 32-bit. Yeah. Just to mark area, you have 32-bit. So you can have any big number as an area ID. So if someone is asking how many areas can I have in OSPF, answer is as many as you want. If you do proper summarization and have multiple area, then your network will support a large size, a big autonomous system. So proper summarization, more areas will improve the network. So there is no limit for having number of areas. And to identify area, you need area ID. For that, you have 32-bit. So there also you don't have limit. Then checksum is for integrity. For layer 2 only we need. So here it is none. Cryptography, it's type 2 authentication, MD5 authentication. We did not mention any key ID, so it is 0. Length of the key is 60. Sequence number, that's for IP packet. And this is the key, the password itself. Right, this is how the OSPF packet will look like. TLV stands for type length value, the authentication unit. If I click DBD, then I will see type 2 as message type. Okay, our focus is on hello packets. We saw all of this. Where did you see stop by area flag? Let me show you. In the hello packet, if you go down under the option here, if you open this, you can see whether this is stub enabled or not. This is called not so stubby area, not enabled as of now. Is it capable of external routing, meaning E2, E1, meaning can we have redistributed routes inside OSPF, bringing RIP routes, all this? This is external. Yeah, it is capable of external routing. So priority. Come again. Is capable. Correct. Is enabled. Yeah. By default, multicast is not enabled, but if you want to enable, we can enable. So as of now, this is what you have by default. Good. So you have already heard few things about multicasting. What are you going to சொல்லுங்க வீட்டில் தான் இருக்கேன் வாங்க வரீங்களா எங்கே போயிட்டு இருந்தீங்க சரி 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 அந்த ஆள் தான் கூப்பிடுங்க ஜோஷுவா தான் கூப்பிடுங்க பெருசா சரி இது நான் கொஞ்ச நேரம் கழிச்சு கால் பண்ணட்டுமா முக்கியமா இருந்தா சொல்லுங்க இப்போ இல்ல பண்ணல அவன் இன்னைக்கு வந்து பேசினான் வந்து விஷ் பண்ணான் ரிச்சர்ட் விஷ் பண்ணிட்டு போனான் இல்ல சரி நான் கால் பண்றேன் ஒரு ஹாஃப் அன் ஹவர் சரி